Okay, so good morning everyone. We're just about 10 o'clock. Welcome to today's webinar. So we are joined today at Databarracks by SolidFire for controlling performance in the cloud, taking charge of your hosting environment. So to kick off with, I'll give you a quick run through of what's going to be going on today. So we'll be introducing ourselves and SolidFire. What we're going to be looking at today are the performance issues with high performance applications, particularly in the cloud. So we've got SolidFire joining us, who are a really interesting company from Colorado in the US, who have a really interesting take on how they solve those problems. We're going to be looking at some of the language of performance and the particular challenges, what are those issues and how they affect each different application, and how flash storage in particular is a really good way to solve those issues. So we're scheduled for 25 minutes today. We'll try and keep as quick as we can, run through so we don't take up too much of everyone's day, and then we've got a bit of time at the end for some Q&A. So as we're going through, we're going to try and get a little bit technical this morning, so if there are any questions that crop up, anything specific, you can pop those questions in on the side, on the sidebar you've got there, and at the end we'll take some time to run through them. Let me pop on. So this is who we are today. As a quick introduction, I'm James. I'm the host here from Databarracks, and our visiting expert over from the US is Stuart from SolidFire. So Stuart, if you'd like to introduce yourself, and over to you.
Thanks, James. I appreciate that very warm welcome. I see you're the invisible man here based on your picture in that slide. So it's great to be here. I apologize in advance if I have a little bit of jet lag, so please bear with me as we go through today's webinar. The goal for today is to really not be salesy. We want to talk about some of the performance challenges for running applications in the cloud. And as my role as the Senior Service Provider Program Manager for SolidFire, I speak to service providers and their customers all day long globally. And so I have a fairly unique understanding and insight into the issues that service providers are experiencing and enterprises are experiencing running those applications in the cloud. I spent a bunch of years in hosting myself, running product management, product marketing, so I have a fairly good understanding of, again, those challenges that enterprises face running their apps in the cloud. Very quickly, we have a couple of draws today. We do value your participation, so we're going to have a poll today with 4 questions. Ultimately, you will see the answers to those poll questions. So we will draw for a sphero ball. It's a robotic ball controlled via a smartphone. And also, at the end of today's webinar, just for showing up, we appreciate it, we'll be drawing for a Samsung 250 gig flash drive, and we'll be announcing those names at the end. So please stay tuned all the way through, and we'll get you in that draw. Okay, so here's the first of the 4 polls. We're going to get this out of the way at the beginning, so we can actually focus on the subject of controlling performance in the cloud. So please, if you will, participate in the poll. The first question is, what applications do you have with a cloud provider today? Are you running virtual desktop? Desktop is a virtual desktop environment, monitoring, a test dev implementation, database servers, or backups and DR. So we'll give you a couple of moments to answer those questions, and then we'll move through into the next one. Okay. All right. Okay, the second question for the poll. What applications are you hesitant to move to a public cloud infrastructure? Is it VDI? Is it customer relationship management? Your ERP applications? Email? Or finally, high-performance databases? Okay, let's move on to the next one. All right. Again, we're going to get these out of the way at the beginning so we can focus on the presentation. The third one of the 4 is, would you put more business-critical applications in the cloud if performance was guaranteed and backed by an SLA?
Yeah, it might be interesting to hear what the answers of these will be like following your presentation. But I guess these are all the issues that we're going to be running through today, and how some of these problems are addressed. And so, yeah, one last question. Let's that's popped through your poll. We'll make sure we ping all the answers to these out to everyone at the end of the webinar, so you can see exactly what everyone else's take was.
Okay, and the final question, what database technologies do you use today? Microsoft SQL, MySQL, Oracle, Hadoop, or Mongo? Mongo being NoSQL. Okay, all right, let's move on here and get into the presentation. So thank you for that. So why is understanding performance in the cloud important? I think for a few different reasons, but primarily analysts are saying that 67% of all workloads will be run in the cloud by 2016. But why do they believe that? Let's take a look at sort of the cloud evolution and how cloud computing started and where it started. What we see here on the left is, most people began early on with test dev, backups, and archive, and also a lot of startups started using that cloud, the cloud 1.0. But as enterprises are looking to take advantage of that cloud value proposition, they want to move those high performance, those more behind the firewall applications into the cloud. And to do that, there's a few different requirements. The service provider, the cloud needs to be support high performance. It needs to be able
to I'd say to chime in on this, I mean, this is the exact route that we've seen certainly in our journey. So we began with obviously offering backup services, and perhaps there's a lot of the folks here on the webinar this morning who take our backup services in addition to obviously the issues of performance in the cloud. They were the first services that you could take with a relatively small amount of bandwidth. We think that's certainly been one of the other drivers. So as internet connectivity has increased, the opportunity to actually use some of these other services has improved. So we're now seeing a lot of our customers asking for exactly this. It's shifting to actually now email in the cloud, and in fact some of the, as you mentioned here, some of the really high performance applications.
Yeah, and from a storage company perspective, we definitely are seeing that migration, right? Especially based on the flash architectures that we brought to market. So why don't most companies, most enterprises run performance applications in the cloud? It's very well understood and known, especially through the storage administrator or network administrator realm, that storage has been the key issue in cloud computing because current storage architectures deliver inconsistent and variable performance. And we'll talk about the noisy neighbor in just a little bit. Legacy controller-based storage architectures don't efficiently scale performance. They do a great job of scaling capacity, but not in performance. And we'll talk a little about performance and IOPS as we move through the presentation here. Legacy storage systems aren't typically able to throttle performance independent of capacity. Most IT administrators believe that I need to buy more disks to buy more performance, and at a certain level that scale just stops. It becomes a flat scale and doesn't work, and you end up having to provision another dedicated array of storage to manage that performance. And also there's has been in the past low levels of transparency. Many service providers offer a portal, but there's no control over that storage performance via that portal. And we all know that transparency into systems makes it much easier for enterprises to host their applications. And candidly, very dedicated storage array costs are prohibitive, and they have a perception of unreliability, especially in multi-tenant cloud applications. So the noisy neighbor, you may have seen this, heard of this term before, but ultimately what the noisy neighbor is when one application in the system impacts all other applications running on that same array. So if a web server or a company gets on a national television show and a lot of people come to their website, the back-end storage infrastructure gladly obliges and tries to provide all of that performance to that sort of noisy virtual machine, if you will, at the expense of all the other applications or virtual machines in the system. What the SolidFire storage architecture does, based on what we call performance virtualization, similar to how VMware virtualized CPU and RAM, SolidFire virtualizes performance in a storage array and capacity. So you could actually provision more performance or capacity as you need. And on the right, the example here is there's 4 performance tiers, similar to how Databarracks provisions their storage. that you could provision a low, medium, high, or extra high performance. And because of the way that performance virtualization allows us to fence off performance, every virtual machine or volume in that system is protected from another. So that if a tenant on that cloud happens to, need to deliver that performance, their performance doesn't throttle any of the other volumes in the system, so it's protected.
And as a quick question for you, actually, Stuart, so we tend to talk about this issue quite a lot in terms of multi-tenant cloud. So if you have several customers all using the same platform, you obviously don't want to be affected by someone else doing something on that platform. But this is an issue that could affect you running your own private cloud in-house with your own applications, for instance.
No, you're absolutely right. Noisy neighbor, even other vendors that use Flash, their hosting vendors that use Flash in their architectures, the noisy neighbor happens whether it's in Flash or spinning disk, or it's in a public multi-tenant cloud, or inside of an enterprise wall. So the ability to solve this noisy neighbor problem is a real key win in delivering next-generation data center services. So enterprise IT lacks storage agility and is under significant pressure to deploy new applications faster, provide more agile and scalable infrastructure, increase that application performance and predictability, that removing the noisy neighbor and delivering a predictable application experience. They're under pressure to enable automation and end-user self-service. Enterprise IT would love to stop the flow of rogue departments moving to public service providers without IT's permission, right? So that self-service is key to maintaining control and manageability of the IT infrastructure. And ultimately, reducing costs of the IT infrastructure is a key motivator for businesses today. Enterprises are looking to service providers like Databarracks that can solve these problems. So let's move into some of the more technical side of it here. We're not going to get too deep, but we should get wet. Why is understanding application IOPS important? So it's important because the way an application operates will determine the workload it generates. And we'll talk about queue depth in a couple of slides to kind of dig into that a little bit. But caching and disk reads and writes all have an effect on how that application creates load on a system. And that's not just storage system, it's networking, it's all the way through to the entire sort of multi-stack infrastructure. However, in multi-tenant legacy clouds, the workloads can be very random because you have potentially thousands of different applications or tenants in that system generating completely random I/O. You could have 1,000 different web servers running different promotions and specials and driving different load on the underlying architecture, which is, from a service provider perspective, we don't really know what's running in there. All we know is that we have a lot of customers running applications. And one of the primary reasons that the cloud has been primarily used for test dev or less critical applications is the unpredictable storage resource availability. So again, that noisy neighbor, the ability to not have a predictable hosting experience relegates a lot of cloud applications to non-critical workloads. And finally, IT simply can't risk the running of key business applications in these unpredictable cloud environments. So key concepts. So IOPS, or input-output operations per second, is really the process of writing to the disk or reading from the disk. That's fairly straightforward. And the specific number of possible IOPS in any system will vary greatly depending on the disk and underlying storage architecture. So from a performance reference here, we have, for example, a 7,200 RPM SATA drive, typically between 75 and 100 IOPS. Old faithful 15K SAS drives for server class, enterprise class drives, 175 to 210. Basic physics limits the amount of performance you can get out of a spinning disk drive. You can only spin those platters to a certain speed, and then they just can't deliver any more reads and writes. And then compare that to a good quality flash drive or solid state drive at around 5,000 IOPS per disk. It's a huge difference. And so to put this into the application perspective, we have, here's some applications on the left, then some general guidelines so that when you're thinking about how Flash is going to implement or impact your environment, what do those applications look like from a performance perspective? I'm not going to go through all of these, but we'll go through a couple. So if you're running a low performance SQL server, you're looking in the neighborhood of around 1,000 IOPS for a low performance instance, 3,000 for a medium performance instance, and close to 10,000 for a high performance instance. Can you imagine if you're running this 1,000 IOP low performance instance in a system that can give you 100 IOPS? Well, what happens? You see increased latency, variable application performance, and really you end up delivering an unacceptable user experience. We'll take a look here more on the web server end here. Let's say you get a Windows VM running, typical Windows web server, Windows-based web server. You got 100 IOPS to 300 to 700. So this will kind of give you some general guidelines as to what your application is going to demand from an IOPS perspective. And then when you're searching for a service provider to deliver that application performance predictably, now you have a little bit more information on questions you can ask them on how to deliver that performance. So queue depth is really important to understand because you could have all the flash drives in the systems or storage architecture that you need, and if you have an application that can only deliver a queue depth of 1, you're still going to see performance issues. So a spinning disk can only serve a single I/O at a time, and seek between those I/Os adds significant latency. In cloud environments where multiple applications or virtual machines share disks, unpredictable queue I/O to a single head easily can result in an order of magnitude and latency. From a single seek at 5 milliseconds to with no contention to close to 50 milliseconds or more based on a busy disk. So this is where Flash really helps service providers deliver that quality of service. Graphical representation of queue depth here. What this shows is really a single I/O to a system, and then you start to see multiple other I/Os queuing up behind it in a spinning disk architecture. And as I mentioned earlier, the more I/Os that are waiting to get their turn to access the read-write head on that disk, the higher your latency is. So understanding queue depth of your application is key. Another consideration here with queue depth is really comparing the single I/O bottleneck of SSDs to spinning disk. Typical spinning disks, like I mentioned, have one I/O channel, whereas flash drives or SSDs have between 8 and 16 channels, and they all serve parallel I/O. So this is the primary reason that flash drives are able to deliver such performance to your applications. However, keep in mind that if your application can only functions on a single I/O at a time, you could have the fastest flash drives on the planet, but if your application can only support one I/O, you're still going to see some performance issues.
And actually, a quick question just to butt in for you here, Stuart. Where do you see people having these kinds of challenges? Are there particular applications that tend to be more problematic for queue depth in particular?
That's actually a good question. So, but it's not an easy answer, so I apologize for that. So there's some applications like Mongo, Cassandra, the NoSQL-based applications really demand a significant amount of performance, and their architecture allows them to do multiple queue depths, so they can deliver that performance. But many times you'll see applications developed in-house and more legacy development languages that only support queue depth of 1 I/O at a time. So no matter what happens, it's hard to get performance out of those applications. So the key thing here is, as I showed a couple of slides ago, to understand the performance demands of your application. There's tools out on the market that you can use to test the queue depth or I/O performance of an application. And I think anytime you're looking at a service provider that you're going into a performance-sensitive architecture is really understand your application, because if you understand your application, you can provision your environment exactly for that application. You don't have to architect it for the high watermark, if you will.
Perfect. No, thank you very much.
So what is Flash ideal for? So, there's a few different use cases that Flash is ideal for, but what we're seeing at SolidFire is that many, just like Databarracks, many service providers use all Flash storage for their entire storage infrastructure. So they can deliver services based on that. But from an application perspective, anytime you see relational databases like Microsoft SQL or MySQL, a lot of companies are moving to virtual desktop infrastructure, right? Delivering the performance to those environments that can handle those boot storms and the patching and the various behind-the-scenes admin activities that need to happen. Large virtualized corporate or what we call private cloud environments, delivering a key amount of performance to a lot of virtual machines. Heavy SAP, Oracle, Mongo, as I talked about, these bigger applications that they'll give you a maximum performance limit when you look at the spec sheets for an SAP or a some sort of CRM application. Well, you can spec your flash architecture, specifically the application, based on the way we deliver QoS here at Databarracks and SolidFire.
I noticed that you actually don't have it here as an example, but it was something you were mentioning earlier. I don't know if you can perhaps not mention the company that was using it, but you mentioned some really interesting case studies for producing a lot of VMs and scaling out very, very quickly with SSD.
Yes, actually, thanks for that reminder. So we have a client in Silicon Valley that I would suggest that everyone on the call knows who they are, but I'm not allowed to repeat their name. So, but trust me, they're very large, and they do a lot of payment processing. They have close to 3,000 developers on staff, and every Monday morning they make a new gold master image of their development platform, and then they roll that out, they clone it to all 3,000 developers. They code on it all week, they check in, check out their code, make their changes, and at the end of the week on Friday, they check those back in. With their legacy storage architecture or spinning disk architecture, it was taking close to 2 weeks to create all of those virtual machines. So in the time between the creation and the killing of those virtual machines, the developers had to work on other tasks. Using Flash and SolidFire's storage architecture, they were able to do that in around 5 hours. So every Monday and Friday, they basically were able to bring that production volume, production efficiency of their engineers up significantly, along with some operational benefits that roll along with that as well.
Thanks. I think, to be honest, it's an issue that's a lot larger than probably a lot of people have to deal with. But I guess it's a good example of that kind of difference that you actually end up seeing with Flash.
Yeah. So there's, and you're absolutely right. I mean, there's not a lot of organizations out there that have 3,000 to 3,500 developers on staff. So we all know that when enterprises are looking for managed hosting solutions, they look around and talk to a bunch of service providers to really try to find the right fit. I would encourage that if you have a performance application that you want to move to the cloud or considering using a multi-tenant cloud infrastructure for, there's really 5 questions you should consider and ask all of those people that are you're interviewing. Can you guarantee storage quality of service for my critical server? Okay. Can you guarantee IOPS to my critical server? If needed, can I add IOPS without changing my volume size or migrating data? And this is key. We know that migrating data is very painful, and if you can add performance without any migration or adding disks or re-rating or striping disks, it's a key thing.
Fantastic. Thank you very much. So as a very quick summary, I guess these are the bits that I know obviously we've been through. It's I guess the key issue, and certainly the reason that we use SolidFire, and we engage with SolidFire just over a year now, and is what we build our infrastructure platform on. It's this ability to have the performance on the disk without necessarily having to over provision lots of storage. And we know that's been an issue for a lot of people. It's not just an issue in the cloud. It's something that the people have when you're running a high performance database, for instance, yourself. So this is something that's key for us, and hopefully if this has been of interest and you like the ideas and things that have been going on, I want to mention, if anyone is attending Cloud Expo Europe, which is on next week at the Excel in London, we'll be there. We've got a stand at the show. SolidFire are also going to be there, and we're going to be running a quick presentation and showing this in action, actually, a couple of applications, how all of this actually works in practice, to give a real demonstration, a kind of a flavor for how it all works. So finally, we'll move on to a couple of questions. We're about on time. We've got a couple through here. So Stuart, if I can put this one to you first. So this question's come in. How do I actually know how many IOPS my particular application will need?
Okay, that's a good question, and I touched on it just a little bit at the beginning, but or during the presentation. But understanding your IOPS is key when choosing a service provider, especially if it's a high performance or an application that needs performance or IOPS. So there's different tools out there that you can use. IO meter, there's Mongo Perf. There's a few different applications you can use to actually test your application and how it's writing to a system. It's a simple benchmarking tool you install, and it'll actually give you what the QDepth is and how many IOPS your application needs. And I think if you have that going into your meetings with your service provider, it really will help them architect your solution for you.
And actually, interesting. So we've actually used some of those tools. In fact, we did some performance benchmarking of our platform to compare against some other service providers. And I think that's a white paper that's available on the website. But for instance, just when you're comparing read speeds, for instance, with the MongoPerf testing, you can do that. And we found that a common level you might see from a service provider would be around 625 IOPS. With SolidFire on our platform, running it wide open, giving it the maximum, we can get up to 15,000. So it's it's a good tool for us to prove to people what's available on the platform. But yeah, certainly really good tests that you can do to work out what your applications were doing. I've got a second question here. So this one I think is perhaps more for us. It's about what are the costs for SSD on our platform. So the way that we charge is based on both the capacity, so the amount of storage, and the performance, so the amount of IOPS. So you can have a small amount of storage with a lot of performance, or a lot with a small amount of performance, and we'll send some information over to you so we can get a bit more detail and get a quote. But if anyone else wants any information on that front, please just pop an email through to sales@Databarracks, or you can contact us through the form on the website, and we'll get back to you with a kind of a more detailed idea for a quote. And then I've got a question here, and actually this was something I guess you touched upon on the last slide, Stuart. It's how can you increase this performance on a volume without rechanging? Is that something that's possible?
Yes. So did touch on it a little bit, and so effectively, because we virtualize that storage performance, we can give you what's called a maximum, a minimum, and a burst amount performance. So if your minimum is set for the service you've chosen with Databarracks to be 200 IOPS, and you realize that you need more performance, whether it's through the Databarracks customer portal interface, or it's through submitting a trouble ticket or a support ticket through Databarracks, you can say, I need more performance, can you give me another 200 IOPS, please? And they can literally log in, or you can do it yourself and just add that performance, and the performance is literally added instantly to your volume. No data migration, it's just like adding another shot to your espresso.
Perfect. And actually, this is one of the things that I think we'll be demonstrating next week at Cloud Expo. So yeah, if you are popping along, make sure you pop and say hi to us. It's it's a simple process of moving a slider, so you can see that in action. And then finally, we've got thanks for sticking with us. Hope this was interesting for you all. We've got the announcements for the winner. So the winner of the SSD is Oliver Fellingham. And the winner of the Sphero ball we've got is Daniel Woolman. So congrats to you both. We'll pop you an email now and get your details and get those shipped out in the post to you. Thanks for staying with us again. I'd like to thank Stuart for popping over and being our visiting expert with us today. Thanks very much, and we look forward to speaking with you soon.